In my previous video, we built a rover out of wooden frame, 3D printed parts, PVC, and recycled parts from my projects years back. The plan is to gradually build a semi-autonomous rover. And now it's time to add in Pixhawk controller. After connecting to a computer via USB, we need to install the rover firmware by clicking Setup, Install Firmware, and choose Rover. This will install the firmware needed for the Pixhawk to function as a rover. Essential components are then temporarily connected to Pixhawk to perform accelerometer and compass calibration. I decided to calibrate these two sensors before mounting to the rover as it is much easier. Upon power up, I did accelerometer calibration, which is basically placing the Pixhawk on all 6 sides. I then proceed with compass calibration by rotating the whole board forward and then sideways. This is to face all sides of the compass to north. This is to capture its orientation. I then mounted the compass on a 3D printed bracket on the top cover, together with the hardware safety switch. I also added a telemetry radio. The cables are then reattached. Using long screws with 3D printed spacers, I mount the Pixhawk and tighten it with nuts. I then plugged the battery to power up the Pixhawk. I also plugged the other end of power module to the motor drivers, but not the signal wires yet for safety reasons. A radio receiver is temporarily connected as it is needed for first-time setup. I will replace it later on with a gamepad. After reconnecting with Mission Planner, we proceed with radio calibration. This is basically wiggling the sticks to its full swing to teach the Pixhawk of the radio's stick limits. The next step will assign as to which servo outputs the left and right motors will be assigned to. Servo 1 will be throttle left, meaning left motor. Servo 3 will be throttle right for the right motor. I also assigned modes on my rotary switch. This will be used to change the mode of the rover later on. Power is then unplugged, and it's time to plug in the signal wires. As previously mentioned, servo 1 to left motor and servo 3 to right. Now, to elevate the rover to prevent it from running off. The rover can be tested manually. After powering and connecting back to Mission Planner, I changed it to manual mode. Once you increase the thrust, both motors move forward at the same speed. Slight left on the roll stick will increase the speed of right motor, causing the rover to turn left. Move stick to the right and it will make the rover turn right. Without thrust, moving just the roll stick to the left will turn the rover counterclockwise on the spot as the motors moves on opposite directions. Moving to the right will rotate clockwise. Up to now, we have been controlling the rover manually. To run the rover semi-autonomously, it needs to know what speed to use. The reason we need to tune the cruise speed and throttle for our setup. Presently, it is populated with default values, but will later on replace with new values. We set auxiliary function switch on our radio to learn cruise speed. We then drive around 50 to 80% of its speed in manual mode, and temporarily toggle the auxiliary function switch to capture the values. Note that the values have changed. I also check the PID tuning, which I'm contented for now. All of this can be found in Ardurover tuning documentation. Now, as I will be using gamepad where throttle stick is spring-loaded, meaning throttle stick is always resting at the center, I need to replace the value of RC3 trim to 1500. This will make the center of the throttle stick 0. You can test this with a transmitter. Make sure to center the throttle stick first, otherwise rover will start moving backwards upon arming. From the center, moving the throttle stick down moves the rover backwards. Roll stick to the left, it will turn the rover towards the rear left. And roll to the right will turn the rover towards the rear right. And now it's time to run auto. Okay, it seems that in my eagerness to run it in auto, I skipped some steps and accidentally crashed the rover. So I may need to print more parts. It turned out that even after tuning, my cruise speed is still too fast, and after crashing on my truck, broke several of its 3D printed parts. While waiting, I also spray painted the frame with white, themed after the Empire's stormtroopers. I then substituted the radio with a gamepad and played it with its manual mode. I added camera for onboard recording and video transmission to ground station. I also adjust servo 1 and 3, min and max, to lower the rover's full speed and make it maneuverable. my next video, we'll be performing autonomous mode for the rover. Thank you guys for watching, and if you like this video, please check my other videos as well.